Kuala Lumpur, Malaysia, one of Southeast Asia's fastest growing cities. A booming Asian tiger. But every year, Mother Nature threatens to bring it to its knees. Tropical storms, raging rivers, massive floods. The solution is brilliant. Carve a single giant road and water tunnel right under the city itself. When rivers jump their banks, the tunnel's road decks will be able to transform into massive flood channels to carry the raging waters under the city streets, leaving the country's billion-dollar economy humming along above, high and dry. Build it wrong, and millions of dollars of property and the lives of hundreds could be at risk. It would be the first combined storm and traffic tunnel in the world, a model for other flood-prone cities. But the threats of sinkholes, massive mechanical failure, and fire will haunt the builders of Malaysia's smart tunnel from day one. This is one of the world's most amazing structures. A 9.7-kilometer long megatunnel drilled through some of the most unpredictable ground on the planet. Amazingly, it's being constructed just meters below the streets of a major city. The smart tunnel will cost more than $500 million to build. It will take over 4 years to finish, and the project's giant tunneling machines will grind through enough earth to fill up over 500 Olympic-sized swimming pools. Kuala Lumpur, Malaysia. This modern Asian metropolis lies at the intersection of two major rivers, the Klang and the Gombak. For more than a century, these waterways were the lifeblood of Malaysia's capital. But now, they may be the biggest threat to the city's survival. Every year, tropical storms lash Malaysia, causing its rivers to rage. When floodwaters reach Kuala Lumpur, the rivers can jump their banks and ravage the city center. Floods like this one leave a cleanup bill in the millions and cripple the city's economy for days. No one knows the problem better than Malaysia's Director General of Irrigation and Drainage, Dr. Kisrul.
Kuala Lumpur is a meeting point of two rivers, and at the point where the two rivers meet, this is a natural depression. It's like a bowl in the river basin. And during heavy rain, this whole bowl gets flooded with water.
Ever since Kuala Lumpur put itself on the map by building the world's highest twin towers, it's been racing to compete with the financial hubs of nearby Singapore and Hong Kong. Leaving its economy at the mercy of nature isn't an option. The Malaysian government desperately needs a solution. The winning proposal is a radical one, a plan that promises to tackle the flooding and the city's worrying rise in traffic delays in one go. The project is called SMART, short for Stormwater Management and Road Tunnel. The SMART concept is surprisingly simple. First, build a massive 9.7-kilometer long tunnel directly under Kuala Lumpur to safely funnel floodwaters from the Klang River at the north to the Karayong River in the south. Then, insert a 3-kilometer long double-level toll roadway to help solve the city's traffic problems. Commuters can travel on the road decks while water flows below in a sealed flood channel. But that's not all. What makes the SMART design truly unique is a feature that would arm the city against a worst-case scenario. If a giant river surge is headed toward Kuala Lumpur, the two road decks could be evacuated and serve as additional flood channels to carry the raging waters underneath the city and spare the country's billion-dollar economy above. It would be the first tunnel of its kind in the world. But building this megastructure just 20 meters below the streets of this major city is a monumental challenge. The ground under Kuala Lumpur is a tunnel engineer's nightmare, full of karstic limestone that can collapse and suck down buildings and even people above without warning. The smart plan is approved, but can Malaysia actually build it and finish the work in time for the next giant storm? January 2003. Malaysia's heavyweights in engineering and construction start work on the Smart. But this kind of tunneling is new to them. The risks of the project are too great to go it alone. The solution is to bring on veteran Hungarian tunneler Gus Klados. Gus knows that the stakes are high, and in tunneling, anything can happen.
I started to work on tunneling sites in summer holidays. And I fell in love with the thing because it's interesting. It's always different. Nothing is ever the same again.
A tunnel warrior, Gus has worked on some of the biggest underground projects in the world, including the Channel Tunnel linking Britain and France.
I worked on the Channel Tunnel, but the Smart Tunnel is much more challenging.
To start, most of his crew have no tunneling experience.
We only had a core of people, professional people who had the experience, and we had to recruit people from the region, from Malaysia and from Philippines and wherever, from the near region, and we had to train everybody on the job.
January 2004. The first of the 2 mega machines start to arrive. It takes 3 months to assemble at the project staging zone. A giant shaft, 140 meters long and almost 30 meters deep in the middle of Kuala Lumpur. To accommodate a stormwater channel and a double-level internal highway, the Smart Tunnel has to be more than 13 meters wide. The fastest way to bore a hole that big is to use some of the largest tunnel boring machines, or TBMs, on Earth. The giant drills custom-ordered from Germany are 71 meters in length, longer than a 747. Weighing in at 2,200 tons apiece, they are almost as heavy as a dozen jumbo jets. At the front, a 300-ton circular cutter head forged from high tensile steel will do the heavy work. A TBM is an amazing machine that both drills and builds. While digging out new earth, the massive drill edges forward. Then it throws up rings of high-grade concrete. These form the lining of the tunnel. From day one, Senior Project Manager Gus Klados is under pressure to complete the project. If any machine can help him do it, it's this one. Each of the Smart's cutting-edge TBMs cost almost $25 million.
This machine has all the features. One could consider it a very luxurious one in the tunnel boring world. This is the Rolls-Royce of the tunnel boring machines.
They're armed with the latest ring-building lifters and hydraulic rams. The massive cutter heads are larger than those used to build the Channel Tunnel. May 2004, the second TBM arrives. Any major damage would require custom repairs in Germany and set the project back months. From this staging zone, the plan calls for 2 TBMs and their crews to dig out. One team will head south to the Korayong River. The other will link up at the Klang River to the north. The job requires the tunnelers to work round the clock for nearly 3 years. It will push the men and machines to the limit. Tunneling finally begins in the South Drive, but immediately there's a problem. the workers are struggling to build the rings. The huge concrete lifters have to be controlled down to the millimeter using tiny joysticks. Malaysian engineer Ang Hao Wei has to keep the men on schedule.
I mean, the first time we didn't know what to do actually. We just follow what they asked us to do. It took about 3 hours for one ring build.
At that pace, the project would take almost 3 years longer than expected and run millions of dollars over budget. And that's not the only risk. Boring these leviathans just meters below the city streets could cause a major catastrophe. It would be the first structure of its kind anywhere in the world. A giant dual-purpose tunnel for stormwater and traffic. If a flash flood strikes, the roadways inside the tunnel could transform into emergency water channels to help steer the surge safely under the city and spare its racing economy above. 20 meters under Kuala Lumpur, Malaysia, Senior Project Manager Gus Klados is under pressure to complete the smart tunnel before the next crippling storm. But his workers are still struggling with the materials and machines. Ahead, the giant drill is already in motion, grinding steadily forward. Behind, concrete segments are on their way to the TBM.
One segment is 10 metric tons, and it is lifted by vacuum only.
Giant hydraulic arms swing the segments into place. It takes 8 segments to build each ring. Just like in an arch, there's a keystone that holds everything together. Using the power of suction, the lifters raise and position each segment down to the millimeter. Make one mistake, and the tunnel lining could crack. Above ground, 2 special fabrication plants are also in full swing, building the concrete segments. Each one contains more than 300 kilograms of steel rebar. They're held together with high-grade concrete, the kind used to build bomb-proof bunkers. The tunnel lining needs to be strong enough to handle the load of a double-deck motorway and 1 billion liters of raging water. At maximum speed, the plants can turn out more than 1,000 segments a week to feed the teams working both the north and south tunnels. Back in the TBM, the workers have finally mastered the machines, and the smart is on schedule. Now, it's a race to build faster and faster.
We are always competing with each other for the ring build. If they build 6 rings, we have to build 7. Okay, if they build 7, we have to try for 8, of course.
While speed is important to the tunnelers, the project's engineers have other worries on their minds. Kuala Lumpur lies on some of the most treacherous ground on the planet. It's a tunnel engineer's worst nightmare, a condition geologists call karst topography. Over millions of years, acid in rainwater has slowly eaten away at the limestone bedrock. The result is a vast underground landscape of cliffs, cavities, and fissures, ranging in size from tiny cracks to colossal caves. In Kuala Lumpur, most people don't know they're there until they collapse and bring down the city with them. From the start, engineers knew that building the smart would require sending the tunnelers and their machines straight into this underground minefield. The stakes are huge. If one of the giant drills hits a large, unstable cavern, it could trigger a monstrous sinkhole. Wherever they occur, sinkholes can come in all shapes and sizes. This one in Guatemala was 40 meters wide. It sucked down houses and killed 3 people. It wasn't caused by tunneling. It occurred suddenly after a major rainstorm. If a sinkhole this large happens in Kuala Lumpur, the results could be catastrophic. It's not the first time engineers have faced this danger. Rewind to 1992. Plans are underway to build the Petronas Twin Towers on a site in downtown Kuala Lumpur. They would be 88 stories tall, the highest twin towers in the world. Together, their concrete and steel would weigh more than 400,000 metric tons. Place that much weight on unstable ground, and the results could be disastrous. So before construction began, geologists launched a massive site survey. And luckily, they made a crucial discovery. Under the planned site was a giant limestone cliff that could have caused the towers above to sink and even collapse. The original site had to be moved 60 meters. But building the smart tunnel would be much more complicated. The Twin Towers rested on just over 18,000 square meters of ground, an area small enough to survey completely before construction started. SMART, on the other hand, has a 10-kilometer-long footprint. Its site covers almost 7 times as much ground as the Twin Towers. Surveying every single inch of this much earth isn't an option. To reduce the risk of collapse, geologists have to probe constantly ahead of the TBMs.
We were probing ahead of the machine, and we were always looking for solution features which were large enough to allow the machine to drop into or tip into, because it would have stopped tunneling for months.
Whenever the surveyors hit a cavity, they pump it full of concrete-based grout. But karst cavities can be less than 1 meter wide, making it nearly impossible to locate every one along the tunnel's entire route. SMART's long underground journey meant that the tunnelers would face new risks every single day, month after month, for almost 3 years. With so much at stake, the choice of TBMs was critical. The way most tunnel boring machines work is surprisingly simple. The cutter head at the front grinds through soil and rock, much like a household drill. The resulting waste is then loaded on wagons and carried out of the tunnel. This kind of TBM is designed for solid ground. If the drill hits weak cavities, like those under Kuala Lumpur, the earth could cave in on the cutter head. A big enough collapse could even suck the TBM down with it. The TBMs chosen for SMART are specially armed. Their advantage is a sealed high-pressure chamber at the head of the drill. This is pumped full of liquid called Bentonite Slurry. The intense pressure of the slurry on the rock face fills cavities before they can collapse as the TBM grinds forward. The sealed pressure zone also provides a barrier between the tunnelers and the unstable ground ahead of them. At least, until something goes wrong. Inside the TBM in the North Drive, there's a problem. The giant drill's progress has slowed dramatically. The team needs to find out why. The TBM's cutter head is armed with 76 forged steel discs to tear through rock and soil. Gus believes the cutter discs have worn down and may need to be replaced. The problem is, the cutter head lies in the forward pressure zone. To get there, the workers have to wait it out in a hyperbaric chamber until it's safe to go inside. The cutter head compartment has been drained of slurry so the men can work. But if the TBM is stopped inside a weak karst cavity, a sudden drop in pressure could cause the ground ahead to cave in. First, shift engineer Hawei needs to measure the cutter discs. To access each disc, he has to rotate the giant drill. One wrong move and the rock face could weaken. The cutter discs are too dull to continue tunneling. They'll have to be replaced. Inside a pressurized cutter head are some of the worst conditions a tunneler can face. It's noisy. It's hot, with temperatures up to 45 degrees Celsius. And there's barely enough space to move. Speed is critical. Every time the cutter head moves, there's a new risk of falling rock and soil. Finally, the first cutter is free. Replacements arrive through a pressure lock. Each cutter is forged from tool steel, some of the hardest metal on the planet, and weighs 200 kilograms. Working in shifts, it takes 64 hours to finish the job. For Gus, the sound of the drill ramping back up to speed is a welcome sign that the problem is over.
You can hear the cutter head starting up now, this wah, wah, wah noise, means the machine is excavating again. The cutter head drive is 4,000 kilowatts, it's quite something. I love this noise. It means the machine is working well. It's fantastic. Hi Rob, what's up?
Keeping the machine serviced and on schedule is Gus's priority. But he also has to make sure the TBM follows a precisely defined path. The ideal route for the Smart would be a straight line, but unfortunately, that wasn't an option. The reason may be surprising: local property law. In Malaysia, property owners don't just own their land, they also own everything that lies below it, all the way to the core of the earth. Since the tunnel's original route would send it careening into hundreds of private property plots, city officials would have to buy tunneling rights from each landowner, including one of Kuala Lumpur's most exclusive golf clubs. And that would have added millions of dollars to the project's cost. The solution was to send the giant tunnel under land already owned by the city, including streets and highways. But now, the Smart would require a series of sharp bends. Turning a 4-story high drill that's as long as a city block 20 meters underground isn't easy. An experienced tunneler, Gus knew what it would take.
We tried to make the minimum curves what is possible with this size of tunnels. 250-meter radius is a very, very small curve for a size of tunnel like this. And as a consequence, we had to buy special machines to be able to negotiate this curve.
A special giant bearing was installed at the front of the TBM to enable the drill head to navigate the tight turns. And high-grade ring segments had to be specially fabricated to make the tunnel lining turn too. Each ring has a thick side and a thin side. If you put the thin sides back to back, you can make the tunnel turn any way you want it. The TBM team is under constant pressure to finish the Smart on schedule. But just behind the tunnelers, another challenge is looming.
When we're building the tunnel, we don't have the access of the whole tunnel. The road deck construction is right behind us, chasing us, if I can say that.
The Smart's design calls for a double-level 3-kilometer roadway to be built inside the tunnel. The problem is they have to construct it less than 300 millimeters above the moving trains that carry crucial supplies to teams working deep inside. Many said it couldn't be done. The solution? To build just 2 key supports on either side of the train track, and then use the lining of the tunnel itself to help suspend huge precast slabs over the train. On top of these slabs, workers can pour the concrete for the road decks, while the train below keeps running round the clock. June 4th, 2005. Across town, one of the TBM teams is reaching a critical project milestone: breakthrough in the South Tunnel. After drilling for 9 months and building 1,067 rings, the South Drive TBM emerges right on target. But risks to the project continue, including what no tunnel operator ever wants to see. Tunnelers are more than 2 years into their big dig to build the giant smart tunnel under Kuala Lumpur, Malaysia. The tunnel will be the first of its kind on the planet, a combined roadway and flood channel that can protect this Southeast Asian city against future giant floods. Critical repairs to the tunnel boring machine in the North Drive brought tunneling to a halt. Now, the giant machine and its crew are back on schedule, racing again toward completion. After 3 years, the double-level roadway is finally open for business. But now, the lives of commuters will be at stake too. Thousands of vehicles are expected to travel through the tunnel every day. In just seconds, a single driver could trigger a major accident. It's every tunnel operator's worst nightmare. A horrific scene like this one. It happened in the Alps, right on the border of Italy and France. It's March 1999. Deep inside the Mont Blanc tunnel, a truck carrying margarine has caught on fire and triggered a raging inferno. Cars and passengers already inside have no way to escape. Flames race through the tunnel, engulfing everything in their path. Firemen are blasted with a wave of poisonous gases and temperatures that reach 1,000 degrees Celsius. 66 people are reported missing. It takes 53 hours to control the fire. When it's all over, 39 people are dead, and the Mont Blanc Inferno will go down as one of the deadliest tunnel fires in history. In Kuala Lumpur, safety officials know that accident and fire will be constant threats to the Smart. The critical question will be, how fast can they control them? From the start, safety has been a key focus of the Smart Tunnel's design. Every kilometer, teams have dug out ventilation shafts and escape routes leading to the city streets above. Every 250 meters, passages connect both road decks. Dozens of closed-circuit TV cameras monitor every inch of the roadways for the first signs of trouble. Waterproof safety lights had to be designed to withstand the force of raging floodwater. At the center of it all, a state-of-the-art control room. Smart's safety team has also been trained for a worst-case scenario. And on April 5th, 2007, that's exactly what happened. Inside the smart tunnel's top road deck, two cars have collided and flipped. In both, injured passengers. Flames start to engulf the vehicles. The control room spots the fire. The passengers are trapped. Rescue crews try to reach the scene, but smoke is filling the tunnel. An alarm notifies the control room that air quality is dropping fast. Fans in the ventilation shafts start to disperse the smoke. Medics finally reach the injured drivers. Firefighters start to douse the flames. The smoke levels appear to be dropping. The passengers are on their way to hospital. And soon the fire is out. Officials breathe a sigh of relief. They have staged this accident to test the SMART's safety team. There's no telling what would happen in a real emergency. But this test, at least, has been a success. The SMART's roadways will reduce congestion and traveling time into the city center. The tolls collected will help repay the $500 million cost of building the SMART. But unfortunately, the risk of a project overspend continues. Tunnelers still have 552 meters to go in the North Drive. Their TBM is chewing the earth 20 meters below a popular commuting route. And SMART's engineers could soon have a potential catastrophe on their hands. The TBM will have to drill extremely close to these, the pylons of Malaysia's national grid. If one of these towers topples, it could shut down power to much of the city. Ensuring the safety of the pylons falls to Senior Geotechnical Engineer S. Satkunasilan.
The three pylons that are in close proximity to the TBM alignment form part of the national grid, and that makes it super sensitive.
As the TBM approaches, Satkunasilan's team reinforces each pylon and carefully monitors it for the slightest evidence of movement. Meanwhile, the giant drill is grinding its way closer and closer. In the TBM's control room, the driver starts to coax it as they near the pylons. He keeps his eye on the slurry pressure. Any drop in the gauge could be a sign that the ground is collapsing under the pylons. It takes 4 days of carefully waiting and watching. Finally, the TBM is past the danger zone. This risk to the national grid is over for now. The North TBM continues to grind its way forward. Now, tunnelers have to commute 5 kilometers into the tunnel to reach the giant drill. The further in they go, the hotter it gets. Giant fans pump cool air into ventilation ducts that stretch all the way to the TBM. The tunnel is like a giant artery, feeding the men and machines inside with vital supplies, power, and a steady stream of concrete segments for the tunnel lining. But when it comes to boring, the most crucial material of all is Bentonite Slurry. The thick gray liquid plays 3 critical roles. It keeps pressure on the rock face to avert sinkholes, provides a protective coating to the giant drill as it grinds forward, and carries the mined waste material back out of the tunnel. Above ground, an enormous slurry plant is working around the clock. Inside, huge machines process and clean the slurry coming from the TBM. The mined rock and soil is separated and sent on to other construction sites. The clean recycled slurry is then piped back underground to the TBM to start its journey all over again. Giant pumps keep the slurry moving round the clock.
This is the P2 slurry pump. It's on the machine. You can see the stones bouncing around in the pipe. This is the heart of the machine other than the cutter head.
The pipes and pumps move enough slurry in and out of the tunnel to fill up more than 600 Olympic-sized swimming pools a month. Any break in the supply chain and the entire project can come to an expensive and messy standstill. March 2007. The TBM and its crew is just days away from their prize, breakthrough point at the tunnel's northern end.
19 more rings to go!
But what happens next comes without warning. A huge drop in pressure on the slurry pipe feeding the TBM. Suddenly, hundreds of liters of thick slurry are flooding the tunnel. The slurry shorts a key electric cable. The TBM grinds to a halt. Now, the tunnelers are 5 kilometers inside the North Drive in almost pitch darkness. They need to find the problem and fix it fast. The only choice is to wade through the thick liquid and search for the leak by hand. Attempts to repair the power lines fail. The clock is ticking. Finally, they find the ruptured slurry pipe. The flood of slurry in the tunnel will have to be pumped out and a skilled pipe fitting team brought in to do the repairs.
We're pumping it out now. When we get the level of the bentonite down, then we can take out the pipe and put the new pipe in.
But there's limited light, power, and access. It takes the teams 3 days to fix the leak and clean up the mess. The slurry system is finally back on track, but there's still a risk for more trouble ahead.
Everything is overused and abused to such an extent by now that anything can break down. And if anything breaks down, we won't make it. People are a bit nervous, including myself.
April 2nd, 2007. Malaysian officials gather at the final breakthrough point, waiting for the TBM's arrival. After almost 3 years of tunneling, the 4-story high drill breaks through. A wave of pressurized slurry announces its arrival. They've finally made it. The $25 million TBM will soon be dismantled piece by piece and shipped back to Europe for its next assignment. For Senior Project Manager Gus Klados, it's been a rough but successful ride.
To complete a 9-kilometer long tunnel, this large diameter tunnel in a city this close to the surface in more than difficult geological conditions, it's something, so it's good to be over.
The workers Gus trained for the job are now experienced tunnelers. They've even broken a world speed record for their type of TBM, building 17 rings in a single day. It's a day they'll never forget.
It's a very special feeling, beyond words. I think everybody feels the same after a few years of hard work. Finally, we break through, and of course, there are more work coming. the day that we should celebrate now. Yes.
Congratulations, guys. Very, very well done. Thank you.
The Smart now reaches nearly 10 kilometers from the Klang River in the north to the Karayong in the south. But just weeks after the breakthrough, a huge tropical storm lashes Malaysia. As water rises in the Klang and Gombak rivers, another flood in downtown Kuala Lumpur seems imminent. The tunnel has been built, but will it actually work? What will happen when the tunnel's roadways are flooded with millions of liters of raging water? A huge tropical storm pounds Malaysia. Floodwaters threaten to cripple the city of Kuala Lumpur. Officials prepare to put their giant new smart tunnel into action to divert water from the Klang River in the north to the Karayong River in the south. They still don't know yet if it will actually work. The smart tunnel was designed to handle 3 different modes. Mode 1 is for normal weather. In this mode, both levels of roadway are open for traffic, and the water channel below is closed and dry. When moderate storms hit Kuala Lumpur, the tunnel will enter Mode 2. The roadways will still remain open. Now, floodwater can flow underneath the traffic. The most critical mode of all is Mode 3. If a giant flood surge is threatening the city, the tunnel roadways will be evacuated and the raging river water can surge down all 3 levels of the Smart. That is, if everything goes to plan. The storm continues to drench Kuala Lumpur. As river levels rise, officials divert water from the Klang River into a holding pond before channeling it into the tunnel. Soon, floodwater is flowing under the road decks. As the hours pass, the river continues to rise. With more and more water filling the Smart, the time has finally come for the tunnel's ultimate test, a Mode 3 surge.
We must put it into operation and to see that it will work as planned and as designed.
If the Mode 3 works, it could save Kuala Lumpur and its economy from more crippling floods. But failure could drop the project into a $500 million sinkhole. All traffic has to be evacuated in less than 45 minutes. When the surge arrives, it will block all escape routes. Anyone left inside could drown. $350mm thick doors seal off the road decks from the emergency exits and cross passages. Huge 37-ton hydraulic gates prevent floodwater from escaping to the city above. With the roadways cleared and sealed, it's time to unleash the surge.
Stand by.
Now, with the tunnel evacuated, the surge should flood the road decks. CCTV cameras are the safety team's only eyes inside the tunnel. They watch anxiously, waiting for the water's arrival. Then it appears. The surge is flooding the roadways. A billion liters of floodwater are now racing down the Smart. Camera after camera tracks the surge's progress as it makes its way under Kuala Lumpur. As the minutes go by, the water fills the bottom roadway. In the upper deck, it's also rising fast. If the engineer's calculations are off, the roadways could crack under so much pressure. So far, everything seems okay. The waterproofed lighting and electrical lines are still operational. The cameras are working. And the safety team is able to control the surge. Finally, the team spots the floodwaters flowing out of the tunnel south of the city. The SMART has passed its final test. It's working exactly as designed. Malaysia's Director General of Irrigation and Drainage, Datuk Kisrul, has been waiting for this moment for years.
With this under our belt, I think we can be confident that we'll be ready when the big flood comes.
It's a brilliant idea to solve a major city's traffic and flood problems with a single tunnel. The challenge was enormous. Kilometer after kilometer of treacherous ground, the risk of collapse and mechanical failure, all just meters under a major city. The SMART tunnel will go down in history as the first mega structure of its kind. An achievement that the men who built it will never forget. Nothing can stop tropical storms from lashing Malaysia. But now, Kuala Lumpur's location at the confluence of two major rivers may no longer be a threat to its growth. The SMART tunnel is one of the modern world's most amazing structures, able to transform scenes like these into distant memories. The next time Mother Nature unleashes its fury on Southeast Asia, it'll be business as usual in Malaysia's booming capital.